Hi, everybody, and welcome back to Chemistry with Mr. McCarson. And on this part four lecture of measurement and calculation, what I'm going to be teaching you today is the rules that govern adding and subtracting and keeping the correct number of sig figs when you add or subtract measurements, and then the rules for multiplication and division and how you round to the correct number of sig figs when you multiply or divide measurements in chemistry or physics, engineering, anything higher level academics. When we measure, we have to account for sig figs, um, even with regards to the mathematical function that we're performing. Okay, so join me on this journey. Let's get started. All right, so one of the things we're going to do is take a quick segue to look at our calculators. Your scientific calculator is going to be a very important part of your journey in a chemistry or physics class. For me, I roll with a TI 36X Pro. That's kind of my favorite scientific calculator that I use when I'm working on keys, setting up problems, writing problems for exams or quizzes. And I feel good about it because I know where the exponent button is and I'm confident in how to use it. So the major thing in this class is we're going to use a lot of really large numbers or really tiny numbers, and your exponent button is going to be critical for many of the calculations that we do today. And knowing where that button is and how to set up scientific notation in your scientific calculator is monumental to success in a chemistry course. Same thing with physics. And then it's also going to be important to learn how to read numbers off your calculator that are in scientific notation and what it looks like on calculators, because sometimes the way the calculator presents a number will look a little bit different than how it looks when you see it on a worksheet or in a test. Okay, so the big buttons that we're looking for traditionally, and once again, it can be different based on the model calculator you have, are the capital E button or the EXP button. Those stand for times 10 to the power of. They're known as exponent buttons. You can also see here, this is a very popular model of Casio. Casio makes nice calculators, and Casio actually does it pretty much the best in terms of they just have times 10 to the x. Like there is your exponent button. So if you want to do 6.02 times 10 to the 23rd, which is a famous number we're going to talk about later, known as Avogadro's number, you would just do 6.02, hit this button, and then type in your exponent, and boom, you're off. So we'll talk about some of the different varieties of calculators, and I'll show you where some of the exponent buttons are. Some of them are a little bit more complicated, some of them are easier, but I'll try to show you some of the popular models here over the next couple slides, just to let you know. And always, if you're ever unsure, especially early on in the class, just take some time during class to raise your hand and call me over. Show me your calculator that you have, and I will try to go over the directions for it with you. I'm pretty familiar with all of them by this point. And remember, for chemistry at the high school level, we don't need a graphing calculator, so you don't need any kind of crazy higher level, very expensive TI. You can find a very affordable calculator on Amazon. As long as it's got one of these buttons, you're going to be okay. You can always show it to me too first. Like if you want to show me a link or something before your parents help you invest in it, that would be a good thing. Okay, so what we would do is, like, let's say we want to enter this number 4.5 times 10 to the negative fourth exponent. What you would do is you push 4.5 in your calculator, then you push either the EXP, the EE, or the times 10 to the X button. Those are the three most popular buttons that I've seen in the majority of calculator models out there. Even in, like in your iPhone, which you can't use on a test or quiz, but like if you turn your iPhone sideways, and I'm not familiar with Google, but I'm sure Android phones have something similar. If you take your calculator that's built into iPhone and you turn it sideways, when it's sideways, you're actually going to see the EE button, and that's your exponent button in iPhone if you're using the scientific feature, which is by turning your calculator or your phone sideways when the calculator is open. Okay, so anyways, after you push EXP or E, a big thing, don't hit the multiply button. One of the common mistakes I see students make is when they're typing a scientific notation into their calculator, they'll do like 4.5 and then they'll hit the multiply button and then they'll hit the times 10 to the x. And basically what that does is it enters multiplication twice and you're going to get one power higher on your answer than you really should get. Okay, so just a tip. Um, See what your display says. Now remember, some calculator models, and I'll show you the one in particular. It's a good model, but it requires you to hit a second or a function button before you can hit the exponent button. But bottom line with calculators, a decent scientific calculator should have an exponent button. You don't need anything crazy expensive that's going to break the bank. You can always check with Mr. M if you're not certain on your button for the calculator. And the sooner you get comfortable with a calculator, this is imperative. The sooner you get comfortable, the better. It hurts my heart. It hurts that the chem gods get disappointed somewhere out there. The metals, non-metals, and metalloids, they cry out in pain when a student on their final exam after 4 months in class still doesn't know where the exponent button is in calculator. Even worse, and I've seen this happen, students, and we do hundreds, if not 1,000 calculations across the whole year, in May will be like, I don't know where the exponent button is. And one of the reasons why they don't is they never took the time and took a small investment into getting their own scientific calculator, or to make sure, like if you do borrow one of mine, I don't have a full class set, but I have enough where you should have one where you use it enough where you get consistent with where the buttons are. So never forget, just always talk to me. Here's a couple more models of calculators coming up. Okay, so these are three very popular Texas Instrument models of calculators that you'll see in class. They range in affordability. Some of these go as low as like $10. Maybe you can get it on sale for a little cheaper on Amazon, all the way up to like $20, maybe $25 online. The TI-36 Pro, this is the one I like just because it has multiple lines and you can kind of scroll through previous measurements. All of these will help get you through higher level math courses as well, up to a certain point. There will come a time where a graphing calculator is a nice thing to have, but you don't need it for chem. Okay, so don't try to sell mom and dad that you need a graphing calculator, because that's not necessary for my class. So in the TI-36 Pro, here's your EE button. This is your exponent button. Very nicely placed, very easy to see right out in front. The TI-30X2S, this is a very popular model. I find a lot of students have this calculator, and it's a nice one. The only trick to this one is before you hit the scientific notation button, it's actually a second function here. So it's the x to the -1, the x inverse button here. And then what you're going to do is you would type in your number like 4.5 using the previous example. And then when you want to do times 10 to the power, you would hit the second button and then hit x to the -1. If you look above it, it might be hard to see on my presentation. There is a lightly colored blue capital E, which is our symbol, one of the symbols used for the exponent button feature. And then you would hit your power like -4. And a quick note, if you do have a negative exponent, most calculators you do have to hit the negative button. Don't hit the minus. There is usually a negative button. That's important to distinguish between. Okay, so the TI-30X2S, and that's a fine calculator. This is another nice one, and this one's pretty straightforward and simple, the TI-30XA, and it's got the EE button right here. There's no second button or function button required to press. This one's a little bit weirder because the way it shows it, like it'll show your exponent here, so this is scientific notation, and that's really times 10 to the 99. It doesn't squeeze in pixels for times 10. The Texas Instrument will, and then the TI-36 Pro does a capital E to stand for times 10 to the power of. So the way that they display their exponents is something we'll also practice in class. But these are all nice models. Texas Instrument makes a good machine, affordable and functional for this class. Okay, here's a couple more sets of calculators just to kind of show you the variety out there. So here's an older model Casio, but I still see these floating around with a number of students, and it's perfectly acceptable. In this version of Casio, this is older, and they didn't do the times 10 to the X button. This has EXP. So EXP is another button that can show up that works as an exponent button. So if you want to do 4.5 times 10 to the -5th, what you would do here is 4.5. Then you hit EXP, then you would hit your negative button here to the -5th or -4th, whatever our example was. But this is a decent calculator. They do work well. It's just an older version of Casio. I noticed the new Casios have replaced EXP with a button that actually looks like scientific notation. It's got times 10 raised to the X. So it's a little bit more visually like, boom, that's what it is. These calculators are the ones that I got as part of my class set. This company, I believe, is a company from overseas, and we get them because on Amazon these are the most affordable for our school budget. And if you borrow a calculator from me, the exponent button is in the bottom middle, and it's kind of blocked off here by my beautiful mug. But whether you get any color of pastel, the students like these because the colors are rad. Like I do like the pastel colors of these KK models, but they use the EXP button. The only thing you got to worry about with these calculators is sometimes if you drop them, they break instantly. So these are not, I think, not the most sturdy models, but they are definitely, if you want to look these up on Amazon, the most affordable model, and they get the job done. So they will do just fine in class. And I've got about 10 of these if you ever need to borrow one if there's an emergency. Problem is I don't have a whole class set, so hopefully this helps you make a choice on a calculator or learn a little bit more about the calculator model you might already have. All right, and so we're gonna get into the rules now of adding and subtracting with Sig Figs, and I'm kind of like grinning because this is something I love. This meme, I found this meme, and it's it just it happens so much. It's kind of goofy. So when you divide something in your calculator and it puts it into a fraction form, some calculators it says like S and there's an arrow pointing from between S and D. You hit that, it will give you a decimal format for this instead of a fraction. But I think we've all been here, and I appreciate the meme culture online. I typed in calculator meme, and this came up, and I was like, yeah, oh, that's gonna happen. That happened to old Mister M quite a few times. If that ever happens to you, talk to me, and I'll show you the button to hit to switch it out of that fraction format. So, anyways, all right. So getting down to business, when we add and subtract with sig figs, remember when in a measurement, the last sig fig in the measurement is the estimate. So essentially, the fewer the decimal places, the worse the estimate is, meaning like it's not as accurate as if you have more decimal places in your number. Okay, or and even some numbers don't have decimal places, they have like to the ones, to the tens, to the hundreds, to the thousands, etc. So your answer when you add or subtract cannot be better than the worst estimate. So like if you have a measurement that goes to one decimal place and you're subtracting or adding a measurement to three decimal places, you can't have three decimal places or two decimal places in your answer. Why? Because that's not representative of the fact that one of your numbers only went to one decimal place, right? So you have to round your final answer when you add or subtract in sig figs to the least place of the worst measurement. Okay, and I'll do an example for that so it makes sense. So you must round it to the least place of the measurement in the problem. No matter how many things you're adding or subtracting, if you have three numbers and you're adding them all together and it's like 5.1, 5.22, 5.333, you're going to round the overall sum to one decimal place of significance because that is the worst of your three measurements. So we'll show that here on the next slide. Okay, so let's do an example here. So let's say that we have two measurements, and we don't have units on these, but take it that they are measurements. Okay, so we've got 27.93 plus 6.4. So how would you go about adding these together and determining the correct number of sig figs to round your final answer to? Step number one, I suggest lining up the decimal places. If you're a visual person, this will make your life easier. So first line up the decimal places. So I would present your mathematics like this. I would go 27.93 and then line up 6.4 underneath of it so that the decimal places align. That's going to be an important first step. Second step, then you want to do the addition. And you can do this straight up the old-fashioned way, or you can do it on your calculator. Remember, for my class, you don't have to do things by hand. It's nice if you can always do them by hand. That will serve you well for a long time and keep your brain sharp. But we got to get through stuff, so using your calculator is perfectly fine. Just make sure you know how to use it. Okay, so when we do the addition here, we get an initial sum of 34.33. Now remember, this is unrounded. This is the raw number, okay? But it doesn't necessarily mean that it's the correct sig figs. Now, when we analyze this, let's take a look here real quick, okay? So we have a first measurement that goes to the second decimal place, 0.93, right? That goes to the hundredths. and our second measurement goes to the tenths. So what that means is our final number, our final answer for significance must be rounded to the tenths place. Now, if we're rounding it to the tenths place, what that really means is we're looking one beyond that at the 100th position to determine rounding. And we ask ourselves the age-old question, does 3 round 3 up or leave it alone? It leaves it alone, right? So our final answer, okay, so we find the estimated numbers in the problem, and I showed you that. So we have 2 decimal places. So the first measurement goes to the second, and then the next measurement goes to the tenths. So once again, basically, like, we have to cut off our number at the tenths position because your final answer cannot be better than the least accurate measurement. Okay, than the least accurate measurement, which means the fewest decimal places, or if we look at like whole numbers without decimals, like which number, like if you have 9,111 versus 9,100. One of those is got Sig Figs up to the ones position, the other has Sig Figs up to the hundreds. And so your final number would have to round to the hundreds for Sig Figs. And I'll show you that on a later example. But anyways, when we round this, the answer must be rounded to the tenths place because it's the least significant. And so our final answer would be 34.3. And that's how it works. All right, everybody, so let's practice a couple of addition and subtraction problems together here. So we've got 56.2356 meters, and we want to add to that 1.92 meters. So first what I'm going to do is I'm going to knock that out in your calculator. If you might not even need it, but you want to get the final sum. So this is going to be, and we want to line everything up. So this is going to be 58, and then we move our decimal point down, and then we've got 1.556. Okay, and this is meters. Now, first, what we want to do is we want to analyze these numbers and see how many decimal places they go out. So the top number is accurate to the 4th sig fig, right? The second measurement is accurate, or sorry, to the, not the 4th significant figure, the 4th decimal place of significance, apologize there. The second measurement is accurate to the 2nd decimal place of significance. So basically, what we do is we draw a line here, and our answer when we add together must round, in this case, to the 2nd decimal place, right? Now, what that really means is we look one beyond. So what we're going to do here is ask ourselves a question: does the 5 in the 3rd decimal position round the 5 in the hundredths place, in the 2nd decimal position? Does the thousandths round up the hundredths, or does it leave it alone? In this case, it would round it up. So when we write our final answer, it's going to be 58.16 meters. And once again, why is it rounded to the 2nd decimal place? Because when we analyze the two measurements, you look and round to which measurement has the least accuracy of significance, which here, if we look, if something goes out to 4 decimal points of meters, that means it's more accurate than a measurement that only goes to 2 decimal points of meters. This one is actually like estimating between 5 and 6 millimeters. This one is estimating to 1 digit of centimeters. Okay, if we kind of think about that literally in terms of meters. All right, here's another example. This one's a little weird because what we've got here is a top measurement of mass, 4.57 grams, and we're adding to it 21 grams. But notice the 21 grams does not have any decimal points. So what do you do if there's no decimal points of significant figures? I will show you. Okay, so first off, we want to add these together, and that's going to be 25, and I am going to bring down the decimal, 25.57 grams, okay? So 25.57 grams is the raw calculation. Now, if we look, we're still going to the least digit of significance when we round. Because we're adding or subtracting, in this case we're adding, we look at, all right, this 4.57 is accurate to the hundredths position. It goes all the way out to the 1/100th decimal position, and that tells us how accurate the measuring device is. But if we look at the number 21 grams, this is much less accurate. It's not even accurate to a tenth of a gram, it's accurate to 1 gram, right? That would be the estimated digit is 1. So maybe this was on a very simple like balance mass device, like a traditional balance where you use like the little gram measurements. So the problem here is our least number of accuracy is the ones. So this is actually what we're going to round to, which means we're going to look at the 5 here for rounding in the tenths. So does this 5 in the tenths position round the 5 in the ones position up or leave it alone? The answer when we round it actually rounds it up. So this would round to 26 grams, and that would be your final answer. Remember, the final answer after you've rounded for Sig Figs cannot be better than the least accurate of the measurements that you added or subtracted, and that's the rule. All right, hope this helps. All right. So in this example, we're going to do a subtraction, and then we'll move on to multiplication and division. So same thing. When we look at our subtraction, we're going to take a look at the measurements, and we're going to look at the least number of significance or the estimated digit in each measurement. So 2,248.3 grams. This one goes to the tenths position for its estimated digit for accuracy. And then we're going to take away or subtract 2,100.158 grams, and this one goes to the 1/1000th decimal position, or the 1,000th spot. Now, when we subtract, we're still going to do subtraction straight up. So when we subtract these, what we get is we get 148.142. So there is the raw outcome in our calculator. Now, what we're going to do next is we're going to draw our divide. So we go to the tenths position versus the 1,000ths. So our final rounded answer cannot be better than the tenths. So we need to round from the 1/100th spot, and we need to determine what are we going to do with the 1 in the tenths. Now, does a 4 in the 100ths position round the 1 in the tenths position up or leave it alone? In this case, everybody, we leave it alone. So our final answer here, when we round this correctly, would be 148.1. And then don't forget your units, grams. It's harsh. It's a harsh reality, but you can do all this math and forget the unit if there is a unit provided. Sometimes for just sake of practice and going fast, we don't have a unit, but we're assuming these are all measurements when we are doing worksheets and practice. And so if there is a unit, don't forget that unit. Okay, let's move on to multiplication and division, which I think is actually the easier of the two sets of rules. Okay, so when we're talking about multiplying and dividing, this is actually what we'll be doing more overall in chemistry. So like in chem, if you ask me like, what do we do more, add or subtract, multiply or divide? We multiply and divide a heck of a lot. So this is a rule you really want to focus on. And I think it's actually the easier of the two sets of rules. I think this one is actually a little conceptually simpler than adding and subtracting, as long as you can count sig figs correctly. If you're good with counting sig figs in your rules of sig figs, this should be a breeze. Okay, so the rule is a little bit simpler. What happens is when you multiply or divide two measurements or more, you're going to analyze each number to look at the total number of sig figs. And then you're going to round your number to whatever the fewest number of sig figs of all the measurements are. Okay? And once again, that sounded a little more complicated than it really is, so let me demonstrate. Let's say we've got two measurements, 3.6, and we're going to multiply that by 653. Okay? So the answer in your calculator is 2,350.8. Now, here's what you do. You're actually going to look at each number and count the sig figs. Okay, so 3.6 is how many sig figs? Well, because they're all non-zeros, this would count as 2 total sig figs. And then we look at 653 as a unique measurement, and we count the number of sig figs in 653. Well, because all the digits in 653 are non-zeros, they would count to 3 sig figs. And we say, which of those numbers is fewer, 2 or 3? Well, the answer is 2. So what's going to happen here is we're going to end up rounding our answer in the calculator to the second sig fig. And we always count sig figs from the left to the right. So there's actually in this answer 5 sig figs in the calculator, but that's too many. Because the rules of multiplication and division, what we know is we can't be better than 2 sig figs because of 3.6. So what we're going to do is we're going to look one beyond the digit that we must round to. If we're rounding to the second sig fig, we're really looking at the third sig fig. Okay, so we're going to look at the third, and it's a 5. So will the 5 round the 3 up? Yes. Now, this does something a little funny here. It's going to turn our answer into 2,400. But what do we do with the 5, the 0, and the 1s and the 0.8? Well, the 0.8 goes away. Like, we can't have a decimal point because it will alter the sig figs. And so the 5 in the 10s and the 0 in the 1s are going to stay zeros, and we are not going to have a visible decimal point. Okay, so this will round to 2,400. And once again, just to reiterate, 3.6 has 2 sig figs, while 653 has 3. So the answer can only have 2 sig figs. You can't have more sig figs rounded to in your final answer for multiplication and division than the least amount of sig figs in your measurements. Okay? So the final rounded answer would be 2,400. And that's the rule. Let's practice. Okay, so let's do an example here for division. So division has the same rules as multiplication, right? And they're equal in PEMDAS, so it kind of makes sense. Now, here's an example. So let's take two measurements. The first is the numerator is going to be 42,888, and we're going to divide that in the denominator by 22.5. Okay, and I want to know what's the outcome and how do you correctly round it to the right number of sig figs? Well, first off, let's knock out the division in our calculator. When you divide 42,888 by 22.5, what you get is 1,906.133333. Great. Good number, just randomized, but it helps to show that you can really do it with anything in your calculator. Now, what we're going to do is analyze these numbers for sig figs. So 42,888, take a moment, is how many sig figs, students? That's going to be 5 sig figs. And we're dividing it by 22.5. How many sig figs is represented in the number measurement 22.5? 3 sig figs. So we've got 5 versus 3. Which one are we going to round to? We're going to round to 3. We can't have more sig figs than what's in the least of the two measurements being divided, right? And so when we take a look at our number, remember we count sig figs from the left to the right. So in our answer, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total sig figs, okay? Now, we don't need to look anything beyond the 4th, right? None of this matters over here. What matters is we have to round to the 3rd sig fig. So we're going to look at the 4th, and we're going to see how does that affect it. So does 6 in the 1s round up or leave alone a 0 in the 10s? The answer is it's going to round it up. So this would be 1,910. And remember, where the 6 is, we have to leave a 0. and we don't put a decimal, so that we have 3 sig figs here in the final number. So the answer should be 1,910. Okay? Remember, we analyzed the sig figs of the starting measurements being divided. So 42,888 was 5 sig figs, while 22.5 was 3 sig figs. So the answer must be rounded to the third sig fig in whatever the outcome in the calculator is. Okay, we round our final answer and it cut it off a little bit. So it should be 1,910 with no decimal point. Remember, you can't just throw a decimal point out there without thinking about the significance of the decimal point. All right, so last slide, let's do one final example of the rules of multiplication and division. Remember, we're going to practice this a lot in class. You're going to be doing labs where we're analyzing sig figs with adding, subtracting, multiplying, and dividing. You're going to be doing worksheets and assignments with this. So I'm going to show a lot of examples in class on the whiteboard. So fear not if these examples haven't been enough. I'll also do some problem sets separately on YouTube where I just crunch examples and practice. If you need additional examples online, they'll be there for you. So here we're doing multiplication, and it's going to be 2.63 meters multiplied by 18.14 meters. And so when we knock this out in our calculator, what we get is 47.7082. And that would be meters. Thank you for bearing with my terrible writing with my mouse. At some point, maybe I'll get a digital pen to do this. We'll see. You can always hope. Now, when we take a look, we're going to analyze our measurements individually for sig figs. So 2.63 is how many sig figs, class? That would be 3 sig figs, okay, 3 SFs. And then we have 18.14. How many sig figs is this measurement? It is 4 sig figs. So what are we going to round our final answer to for the product? We're going to round it to the third sig fig. So we count from the left. We've got sig fig number 1, 2, 3, and then 4. And remember, we don't need to look beyond that. You never double round. So if we're rounding to the third sig fig, you don't look at this 8 or the 2 for anything. You simply look at the 4. Does the 4 round the 7 up, or does it leave it alone? In this case, it leaves it alone. So our final answer here should be 47 decimal point 7 meters. And that's the correctly rounded product to what sig fig? To the third. All right, everybody, I hope this helps. We're going to practice a lot in class, and trust me when I say that it's August right now. The date I'm recording this is August 26th. You will use this all the way to the final exam in May in the second semester. These skills are that important, and you'll carry it with you hopefully into physics and a lot of higher level, really cool science courses and engineering courses and mathematics later on in life. All right, everybody, I love you. Thank you for staying with me on this journey. I promise you, we're almost to the atoms once we get through a few more concepts in measurement and scientific calculation. And have a great day. I'll talk to you later and see you on the next video. Bye.